In this first video of our OS series, I will explain what an operating system really is, why we need it, where we find OS in real life. The whole series is designed for BTech students and anyone who wants to understand OS deeply but in simple language. Suppose you are using your phone right now. You have Instagram open, maybe BGMI running in the background and maybe other games and downloads will be going on. In another case, think your laptop. You have VS Code, Chrome, maybe Spotify, all open together. Now the thing is like, ever wonder who is managing all of this? Who decides which app gets the CPU? How memory is given? And why your system doesn't just die every time you open those 10 things or many more? And for that, the answer is simple. It's operating system, or maybe you will calling OS. Let's start with a simple picture. As you can see the screen, at the bottom we will be having hardware, nothing but disk, RAM and CPU. And keyboard, mouse, network card, all these are physical parts of the computer. At the top, we will be having applications like browser, games and code editor, like any program you run. So, in between these two, we have an operating system. An operating system is a collection of software that manages your computer's hardware and provides service to applications. It allocates CPU time to different processes, manages memory, and decides where each program's data live, like control devices like keyboard, mouse, screen, and network, etc. If you want to know about in a short, like OS is the manager of your computer. Hardware is like workers, apps, or like clients, and the OS is the manager that coordinates with everything. Comment below like which OS do you use most, Windows, Linux, or Android. Now the big question is, why do we need an OS? Imagine a computer without an operating system. Every app would directly try to control the CPU, memory, disk, and sometimes keyboard, mouse, network, everything. So, what will be the condition in that way? Each developer has to write hardware specific code. One buggy program can overwrite another program's memory and crash everything. Sharing devices like printers, disks, or network becomes a nightmare. That's why we need an OS. Now, think a laptop which is built in with OS provides a safe environment for programs to run, gives standard interfaces, nothing but system calls, so apps don't deal with low level hardware details. Ensure protection so one app can't randomly access another app's memory or files. So the benefit of OS is nothing but converts raw hardware into a system that is usable, safe and convenient with the help of system calls. So operating systems are literally everywhere. On laptops, desktops, you will be having Windows, Mac OS or Linux. And coming to the phones or mobiles, you will be having Android or iOS. In servers and cloud data centers, most machines run some flavor of Linux or Windows Server. Even small devices like routers, smart TVs, or EV cars or smart cars, washing machines, and IoT devices have some customized OS inside. The core responsibilities are always same for all these things. Manage hardware resource, run programs, and provide security and reliability. Think of the OS as a layered surface. At the top, we have user space. This is where your normal applications run, like your editor, browser, shell, and libraries. At the bottom, we have kernel space. This is where the core OS code runs, the kernel and the device drivers. This part will be having full access to hardware. Why we need to separate them? User space is restricted. If a user space program crashes, usually the whole system doesn't crash. But if a kernel space is a powerful, like here, even if a small bug is present, it can have, and it can affect the entire system. So OS exposes services from kernel space to user space using system calls. When your program wants to do something like open a file, create a process, or read from disk, it doesn't touch hardware directly. It makes a system call to the kernel. The kernel then performs the operation safely and returns the result. In the next video, we'll be going deeper into how system call works, what the shell does, and how a simple command flows in Linux. Let's quickly connect this with something you might have seen in Linux labs, the shell. When you type a command like ls-l in terminal, the shell or like bash reads your command. It figures out which program to run here. The f- I mean that program uses system calls like open, read, or write to ask the kernel for directory contents. The kernel reads the data from disk and sends it back. Finally, the program prints the result in your terminal. So the shell is simply a user space program that gives you a text-based interface to talk to the OS. In the next video, we'll be going to, in the next video, we'll slow this down and draw every step of this command. Now let's see the big components of any operating system. Every OS, whether Windows, Linux, or Android, mainly focus on four big areas. One of them is process management. Process management, a process is basically running program. The OS creates, schedules, and terminates a process. It ensures that multiple processes can run safely without corrupting each other, without disturbing each other. The next one is memory management. Every process needs memory to store its code and data. The OS decides where in RAM each process lives and how much memory it gets. It protects one processor's memory from another and uses virtual memory to handle big programs. File system management. Here OS organizes data into files and folders on disk and SSDs. It handles file creation, deletion, reading, writing and naming, etc. All those things. Coming to device and input output management, OS talks to device like keyboard, mouse, printer, disk, etc. It uses device drivers to hide hardware details and expose simple functions to app. Along with these, OS also provides security, protection, error detection, and performance monitoring. And I think your BTech syllabus will be basically thinking on all these big areas and it will be going deep into each one of these. So this is what we'll be doing in our channel step by step. And I will try to explain as much as possible such that you will be getting full understand and knowledge on the OS in this series. Now we will see how operating systems are actually built and improved. Most OS kernels are written in low-level language like C or C++ because they need to be close to hardware and extremely efficient. Inside the kernel, engineers work on different components. Scheduler, which decides which process runs next on CPU. Memory manager, which handles allocation, deallocation, protection, and virtual memory. The file system, which defines how files are stored, organized, and accessed. Device drivers, which know how to talk to a specific hardware like GPUs, network cards, printers. When people improve an OS, they might design smarter scheduling algorithms to make system feel faster and efficient. Optimize memory management to reduce fragmentation and increase efficiency. Strengthen security and protection mechanisms. In later parts of this series, we'll connect these ideas to real examples from Linux and some of the BTech students will be watching this. So we can match this to your syllabus so you can see both concepts and practical designs. Let's quickly recap what we did in this video. We defined the operating system as main system software that manages hardware and applications. We saw why we need OS. Without it, what would be the disaster or what would be the situation? Security problems and no easy way to share resources. We looked at where OS is used, like PCs, phones, servers, and even small embedded systems. We introduced the idea of user space versus kernel space and system calls as a bridge between them. We also outlined the four big components of OS. One of them is process memory, file systems, device input output management, and the last one is security and protection. From the next video onwards, we'll be going deeper into the OS architecture. then processes and CPU scheduling. If this video helped you to understand the basics of OS, hit the like button so I know this content is useful for you. Comment which topic you are most scared of right now, like process memory, kernel space, or user space. So I will prioritize that. And subscribe and then hit the bell icon so you don't miss the part 2 of this OS series. See you in the next video where we'll be talking about user space, kernel space, system calls, and shell more detail.